Alright, so there's your equation. I don't know if you already know how to do like just the implicit differentiation part, but I'll just do it anyway so you can have the whole thing. So basically you just derive it, or take the derivative as if it were just like a regular equation with no y's in it, but every time you take the derivative of a y, you just multiply that part by y prime, so it's exactly the same. So basically like 4y squared, if this were just like 4x squared, it would be 8x as this derivative for this part, but since it's a y, it's just 8y times y prime. So just anytime you take the derivative of a y, you just multiply it by y prime. So starting with the derivative, we get 8y, and then this part's a product rule, so we get the derivative, backing up, this is 8y, y prime, stupid me, plus the first, x times the derivative of the second, which is going to be 1, but again, y prime, because you took the derivative of a y, plus the derivative of the first, which is 1, times the second, y, and this is going to be minus 2x plus 0 equals 0. And once we clean that all up, we'll get 8y, y prime, plus xy prime, plus y, minus 2x equals 0. And now the idea is just to isolate the y prime so you can set the equation equal to them. So we're going to put this crap on the other side. We'll get 8y, y prime, plus xy prime equals 2x minus y. And then we can factor out a y prime here and get y prime times 8y plus x equals 2x minus y. And then just divide out this whole thing here, and we'll get y prime equals 2x minus y over 8y plus x. So here's your derivative. Now you want to find the equation of the line that passes through the point, the point on this equation, x equals 2. And so to find the y part of that coordinate, all you're going to do is plug in this 2 into there. And because it's like, think about it, like if you're trying to find the line tangent, it's going to be on this line, or the point at which you're trying to find the line tangent to is on this line, and you're given one part of that coordinate, and so if you just plug that in, it'll just spit out the y part. So we'll just get 4y squared plus 2 times y minus 2 squared plus 4 equals 0, and just solve for y now. 4y squared plus 2y minus 4 plus 4, those cancel, so equals 0. Then we can factor out a y, so we'll get y times 4y plus 2 equals 0. So we have y equals 0 and 4y plus 2 equals 0. So 4y equals negative 2, y equals negative 1/2. So since this basically says, okay, so I looked up what the graph looked like online, and it was something like this, like here's your little coordinate plane, and it was like that and like that. And so basically at this point here, that's x equals 2, and so with this graph, there's 2 places at which it goes through x equals 2, so you can actually find 2 different equations for the tangent line at the point, or at the line, or on the line x equals 2 going through this this graph. So I don't know if your paper or whatever you're doing just wants you to do one of them, or if you're supposed to do both of them, but I'll just do one of them and you'll get the idea. It's not that much more work to figure out the second one. So we'll just do the y equals 0, and then if you need to, you can go back and do the y equals negative 1/2. So you have this equation called the point slope form of a line, and it goes y minus y1 equals m times x minus x1. And so basically this is what you're just going to plug your coordinate into. But m, remember, a derivative is just the slope of the tangent line to whatever you took the derivative of. meaning that this is the slope of any tangent line of this equation. So basically all you're going to do is plug in the point 0, because we're working with the point 2, 0, because that's we found the y was 0. So we're just going to plug that in first. We'll go back up here. So we'll just say m equals 2 times 2 minus 0 over 8 times 0 plus 2. M equals 4 over 2, which is 2. So there's your slope. Next, we can just plug everything back into that other equation. Y minus 0 equals 2 times x minus 2. And so we just end up with y equals 2x minus 4. There is your tangent line. And if you wanted to do the other point, all you would have to do is just plug y equals negative 1/2 back into your slope equation, or back into, instead of 0, you're going to plug it into here as negative 1/2, and also in this equation here. I guess I'll just do that anyway, just because I feel like it. So I guess we could just call this like m1, and this could be like, I don't know, y1, whatever. So you could just say m2 is 2 times 2 plus 1/2 over 8 times negative 1/2 plus 2. So m2 is going to be 4.5 over 4 times, being stupid here, what is that, negative 4 plus 2, negative 2, which is 9 over negative 4, negative 9/4. So then you plug that back in, y minus, I guess, plus 1/2 equals negative 9/4 times x minus 2, and then I hate fucking around with fractions, but y plus 1/2 equals negative 9/4 x plus, what's 18 divided by 4? I'm just going to write down and simplify later. And then this is the same as 2/4, and so we'll just end up with y equals negative 9/4 x, and you're subtracting that 2/4 over, so plus 16/4, which is just 4. So your final equation is going to be y equals negative 9/4 x plus 4. So those two should be your equations. Try to scoot this over so you can see that and that. I don't know if you have an answer key, but that'd be really helpful if you did, just so you can make sure I'm not a dumbass. There you go.